Hey there, everybody. We'll start in just a minute or so. This is a continuation of what talked about actually yesterday on function composition. Last time we did writing a new rule, so you can look at that if you need to. This time we're going to look at evaluating it at a specific value. All right, basically plugging a number in rather than just having an expression. These answers, when we're all done, will, I guess you can say, look nicer, quote unquote, than the answers for the previous bit. There are two methods that I'm going to talk about. One of them piggybacks off of what we did in the last one. That's why we did that one first. And then the second one is kind of a more, just kind of a plug and chug sort of route I'm going about it. So in just a minute or so, we will get going on this. I am going to want to go over a couple of terms first. Hey. All right, let's go ahead and start talking about this here. A quick recap of some vocabulary. This statement here is going to be read as f of x. Okay, this one here, if you remember, is going to be g of x. Alrighty. And then both of these, this is using both notations. This one here, which is probably a little bit more intuitive, and then this one here, which you might also encounter, but both of them are read as f of g of x. Okay. And then finally, this one here. This one, where there's not an x here anymore, it's become a, excuse me, easy to say. This becomes a 3. Doing all right. It's just another day of distance learning. We kind of already stopped doing new material a few days ago, so yesterday's date wasn't really all that important for us. Let's see. So this one's going to be f of 3. All right. So in this instance, 3 is going to be the input to our function, and it replaces any and all occurrences of x. Alrighty. So here we go. Method 1, use the new rule. Okay. For this one here, we're actually going to start by finding f of g of x. All right. It seemed that when we were doing this in regular school, this was kind of a favorite approach for a lot of you guys. So that's why I'm doing this one first. But basically, since g of x is inside, okay, we're going to take f, and every instance of x, we will replace it with a set of open parentheses. Remember, that was a big idea before. X becomes open parentheses, or empty parentheses. Okay, so we've got 3x minus 5. And we'll put g of x in there. So that's 2x plus 1. And just like we do when we're creating a rule, we're going to go ahead and distribute that 3. You'll have 6x plus 3 minus 5. And then finally, we will combine like terms 6x minus 2. and that is f of g of x. All right, so now that we have the new rule, we can go ahead and evaluate it for the number 3. So we're going to take that rule and write it down. Same process, we're going to replace the x with empty parentheses. So we've got 6x minus 2, and inside those parentheses we will put the number 3. Okay, you could do it by hand, or you can just plug it into a calculator. If you're using a scientific calculator, one of the TIs, honestly pretty much anything but a TI 34 as far as scientific calculators go. I'll be honest, I can't stand that one. I hate it when people come to my class buying that one. But 34 multi-view, 30 multi-view, even a regular 30, of course the 36 Pro, all of those will do this just fine when you're just, plugging it in. But, well, you end up with 18 minus 2, so 16. And that is the answer. So you can say that f of g of, oops, not x this time, you fool, of 3 equals 16. All right. So that's that one. Just to be consistent, I do have the reverse going on down below. It says g of f of 3. If you're not a fan of this notation, you can go ahead and rewrite it at any time. G of f of 3. All right, you really are doing the same exact thing. We'll start by writing g this time, and that's going to be 2x, replacing it with parentheses, plus 1. And then inside those parentheses, we'll put 3x minus 5. Okay. Distribute. This time we have 6x. You know what? I do not feel like continuing with that color. There we go. 6x minus 10 plus 1. Combine like terms, 6x minus 9. And that is our g of f of x. There's a nice looking f. Kind of looks like a forte. Now we're just going to do what we did before. We're going to take the new rule, replace the x with empty parentheses again. And inside those parentheses, we will put the number 3. Okay. Once again, you could do it by hand, or you can use a calculator. If you're doing it by hand, let's see, 6 times 3 is 18. 18 minus 9 is going to be 9. So we'll say that g of f of 3 equals 9. And I use that notation for the end simply because that's how it was started off. It really doesn't matter. Both that and the parentheses 1 mean the same thing. All right, so that is how we're going to evaluate the composition of two functions by using the new rule, the composite rule. Here's the other way. This is the one that, honestly, when I was teaching it, I almost expected this one to be the more popular one, but for whatever reason, students seem to like the other one more. But basically, guys, you're going to have h of whatever this is, okay? So p of negative 2 is going to be what goes inside there, okay? So we need to evaluate p of negative 2. As before, we will replace the x with empty parentheses. So we have 3x plus 7. And inside there, we will put the number -2. All right, and you can use your calculator or whatever. You get -6 plus 7, so the answer there is 1. Okay, so P of -2 equals 1. That's this statement right here, P of -2. So that's going to be 1. Inside here, I'm going to put, I'll draw it that way, the number 1. Alrighty. And we just continue again. Now we're using h. This time it's going to be x squared minus 4. X gets replaced again with empty parentheses. And inside those parentheses, we will put the number 1. Using your calculator or by hand, whatever makes you happy, you're going to do 1 squared minus 4. And that gives us -3. So h of P of -2 is -3. All right. We're doing good all right so far? One hopes. Okay, just one more. We're going to do the reverse. It is written using the alternative notation. Okay, we're doing P of H of -2. That means we're going to do P of H of -2. It might be a little weird to think of it this way. If you want to go ahead and rewrite it as P of H of -2, you can. It looks a little bit more like what's actually happening. All right. But either way, we do need to find H of -2. All right. So empty parentheses, squared minus 4. Okay. So this is one of those places where having the parentheses really makes a difference. Okay. If you don't have parentheses here when you plug -2 into that, you're going to get the wrong answer. Okay. If you type it in exactly this way, okay, you get -2 squared, which is +4 minus 4. You end up with the number 0. Okay. If you just think of it this way, -2 squared is -2 times -2, and negative times negative is positive. If you were to type this into your calculator, what it thinks you want is the negative of 2 times 2, and that is totally not what we want. Okay, so definitely be very careful of how you enter it. All right, so we know now that H of -2 is 0, and that's going to be what goes right in there. We'll put the number 0. And the process repeats again. This time we're going to do P of 0. Let's see, what was P? 3x plus 7. Okay, so it's going to be 3x plus 7. Inside those parentheses, we will put the number 0. And then you can just pop that into your calculator. You end up with 7. So we can say that P of H of -2 equals 7. And there you go. That's it. So that's 2 examples of evaluating the composition of 2 functions. The first method, if that's your favorite, go for it. That involves writing the rule first and then evaluating it. That keeps your methods consistent between doing it this with a number versus not having a number to plug in, or that second method is also fine. But if there's no other questions, I'll sign off, and I'll talk to you later. All right then. Have a good one.